Hello everybody, welcome back to Universe Sandbox. We are doing your guys' suggestions again today, and we're gonna start with this one, which says, make the sun reach out to the Earth's orbit and see what an eclipse looks like. So we're gonna make the sun stretch all the way out to where Earth is, but we don't want it to eat Earth, so let's see if we can do this. Okay, so we're just going to try to turn up the radius like this. You can see the sun growing. So you can see it's eating Mercury and Venus. We'll go a little more. We don't want it to fully eat Earth. No, go back. Okay, Earth is still there. Okay, so to see what an eclipse looks like out here. Okay, so here's the moon. Let's put the moon between the Earth and the sun. Okay, and then if we land right here and look up, that's an eclipse. Oh boy. Okay, we're gonna press play on the simulation and see what happens. Let's set it to real time. I think the sun might supernova because of the low density. Oh, it's growing even more. Oh, look, yeah, it's exploding. Look at that. The sun was so light and like not dense that it exploded. The Earth is still here though. Let's see over time if this burns up or what. Nothing? What? It's actually pitch black. So I think that the Earth is fine. 92% chance of life. I guess the Earth is fine from that. That is weird. But over time, obviously, the sun's not here and it will fly off into space just like all the planets, and it will freeze and we will all die. All right, our next suggestion says, put the Earth in the center of the solar system and try to make it so that the planets still move around it. Okay, just delete the sun and delete the Earth, and then we'll put a new Earth right in the middle. We're gonna have to make the Earth a lot bigger for this to work. Okay, the Earth is now in the middle. You can see that. We need to make this a lot more massive. The only thing that's going to keep the planets in orbit is if the mass is the same. But if we turn this up enough, it's going to turn into a gas giant because a planet cannot have that much mass. It might actually just turn into a star, but we don't want that because we want to try to keep it a planet. It's shrinking now. It's getting more dense. Okay, something very weird is happening. Okay, it's about 10% of the way there. Okay, it's still technically... Okay, we did it. It's the mass of one sun, but I'm pretty sure as soon as I click play, it's going to turn into a star. Okay, 3, 2, 1, go. Yeah, okay, you can see it turned into a dark star. But it does keep the planets around it. How do we make it a planet? It's growing. If I turn the radius down enough, can we turn it into a planet? Or this is just going to turn it into a black hole? I don't know. Oh, it's a planet. Let's see. No, it cannot hold on, unfortunately. Okay, this is going to be kind of weird. Make a star and make the luminosity as big as you can and make a habitable planet. So basically, we're going to make a star as bright as it can possibly be, and then see how far away we have to put a planet for that planet to have life. So let's put the sun in a random simulation, and we're going to set this luminosity. And this isn't just the brightness, it's also the energy output. It's like the heating. So this is gonna make it super bright and shoot out a lot more energy. How high can we make it? Okay, you can see it's starting to turn blue as we make this higher. I'm gonna keep hitting this. Okay, well, there's a point where it just disintegrates, so we need to make it before that point. Okay, once it starts to go blue. Okay, I think this is pushing the limit. It is that many times more bright than the sun. Okay, it disappeared. That was beyond the limit, I guess. Okay, once it turns blue, we're gonna stop. Right there. Okay, it is very, very, very bright. I'm gonna speed up time to make sure this isn't gonna disintegrate again. Okay, it looks good. Let's see just where the habitable zone is on this star. So to put this in perspective, Earth is 1 AU away from the sun. So we can't even see the red yet. That's because the habitable zone is on. So Earth would be right here, but we got to zoom out. Okay, we can barely see the red now. The green is 0.1 light years away. That's the unit of measurement that they're using, is light years. So let's put a random planet in this area, 0.1 light years away. That is crazy. It would take about a month for the light from this star to reach the planet. That is crazy. Okay, we're gonna set the atmosphere to, we want no sulfur dioxide in it. Okay, that's looking better already. We need nitrogen. 70% of it to be nitrogen, 10% oxygen, and no sulfur dioxide. I don't know where that's coming from. Where's the sulfur dioxide coming from? It keeps coming back, but we're gonna leave it like that. Let's add some water to it, the ocean. We want it to be a water ocean, not anything else. Oh, but look, the ocean is not water. What is it made of? I don't know. What's our life likelihood right now? 0. Terraforming is so hard, but I love it. Like, it's so cool to have all of these options. I'm gonna do a different planet actually, because I think that one is weird with the sulfur dioxide. Oh, this one it wants closer. We're gonna put it about 0.1 because we're gonna adjust this to be like Earth. Okay, this is looking better. Yeah, nitrogen in the atmosphere. Yeah, it's 50% nitrogen. We want 0% sulfur dioxide. Okay, it's not going back. That's good. We want some oxygen in here. We'll go 10% oxygen. What if I just throw water on it? Okay, that seems to work. It's like when it's at 0, it like won't let you add anymore. Now can we adjust the sea level? Oh, see, now it's not doing water. It's doing carbon dioxide ocean. I don't want that. I want water. Okay, does that have any now? 5%. So it is possible to get life out here. I need to get better at terraforming in this new update. But the ability to do all the things we can do now is actually really cool. You can see how far the sun really has to be. It's the same size, but it's so bright that even at 0.1 light years away, it still lights up the whole planet. It would be like a tiny star, like the size of a star, but it would be so bright that looking at it, you would go blind, like the sun now. So it is possible. It is very hard to do life with a high luminosity star. Okay, our next suggestion says make Earth have 15 moons and see what will happen to the orbit of Earth. Okay, so we're gonna pause it. 15 moons, it says different size and mass. So we're just gonna go random moon. We'll see what happens here. We're gonna do some pretty big moons. 1, 2, 3, 4, 5, 6. We'll go up and around. Okay, is that 15? We'll do a couple more to be sure. It's at least 15. 3, 2, 1, go. Oh no, we went way too fast. But you can see it threw Earth out of the solar system. Let me do that again and we'll do it slower. Okay, we need this to be a lot slower, like 2 hours a second instead of 16 days every second. Yeah, that's better. Okay, pause it. We'll do this again. Random moons. We'll see if the same thing happens. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15 very large moons. And we will go a lot slower this time. Here we go. See what happens here. Oh, that one almost hit Earth. You can see lots of eclipses happening. Oh, 2 collided right there. There's an eclipse happening. Another collision. Oh, 1 hit Earth. That's not good. Okay. Okay, are these ones in orbit? Definitely not stably. Okay, another collision with Earth. Another one. Oh, another one. Oh, more. They're all hitting Earth over time. I think we might be left with Earth in orbit and some weird elliptical moons after this. Oh, Earth got hit again. But it is still in orbit this time. Oh, something just happened. What just happened? That just flew it out of the solar system. That is crazy. It is going straight down, never to be seen again. Okay, and for our final suggestion today, it is delete the planets, but let their moons orbit the sun. Okay, this is actually kind of cool. So let's just try it with Jupiter, because Jupiter has the most moons. So let's add its moons. Okay, so here's all of Jupiter's moons. You can see there's a lot, a decent amount. So if we just delete Jupiter, what's going to happen? Are they going to fly out or are they going to start orbiting the sun? Let's see. Go. Looks like they're all going to orbit the sun. You can see those are that's their orbit. Let's go their trail. So if Jupiter, okay. A lot of them are actually flying out. A good chunk of them are starting to kind of form like a new asteroid belt and fly around the sun. Io is gone. Callisto is gone. So Europa is gone too. So a lot of the main ones are gone. But a lot of these smaller ones kind of join the asteroid belt. And you can see they all meet up where I deleted Jupiter. And then they kind of spread out and then all meet up there again. Wow. Okay, I'm going to do that with all the planets. This is going to be a lot of particles because there's a lot of planets. So if I just go and delete all of the planets, but not delete the moons, Jupiter, delete. Saturn, delete. Uranus, delete. Neptune, delete. And then playtime. We'll see how fast I can run this simulation. Oh, okay. You can see all of the planets and their moons are, a lot of them are being shot out, but a lot of them are actually going to start orbiting the sun. And if we let this run long enough, like millions of years, I would assume that a lot of these would start colliding and we could even see new planets form. So after lots of years, a lot of them fly out, but a lot of them start orbiting the sun. We have a lot of little planets now, basically. All right, thank you guys so much for watching this video. Leave your suggestions in the comments on this video or any of my videos, really. Join my Discord if you haven't. Thank you for watching, and I'll see you guys in the next video.